Okay, good morning. This is Professor David J. De Los Reyes. Okay, it's October 7, 2023. The time is almost 3 a.m. Okay, my topic for this session will be a continuation of my college algebra. Okay, we are almost done with the college algebra. I think we got one more topic. I will add up partial fraction with my college algebra. So when you reach integral calculus, okay, you got all the foundation on how to integrate integrals involving partial fractions. Okay, so the next time around, the topic will be partial fraction. But for tonight, this will be the last part on the topic equation of parallel lines and perpendicular lines. Okay, let's proceed. The topic for this morning will be college algebra, lesson number 84. We are now on lesson number 84. We are almost done, okay? And the title of the topic is parallel lines and perpendicular lines. Meaning, what are the relationship of the slope of parallel and perpendicular lines? Uh, Parallel lines are actually lines in which I think the definition is that these two lines will not intersect, okay, no matter how long they are. An example of this will be the railroad. The railroad or the rails of a train is actually a parallel line, okay? The example of a perpendicular line, what will be a good example for a perpendicular line? Perpendicular lines are just lines that in which the angle between them is 90 degrees. It is something like this, right? One example of a perpendicular line is the rectangular coordinates and the y-axis and the x-axis. They are perpendicular lines because the angle between them is actually 90 degrees. Oh, that is a good example of a perpendicular line. Okay, let's proceed. There are four concepts on the study of lesson 84. I add up the equation of a vertical line and the equation of a horizontal line. Vertical line and horizontal line are actually special cases, but at least we know how to get the equation of a vertical line and a horizontal line. But before that, we'll discuss the parallel lines. For parallel lines, the relationship of this slope is that M1 is equal to M2. If this is the y-axis, this is the x-axis, if this is line number 1 and this is line number 2, the slope of line number 1 with respect to the horizontal, it's always with respect to the horizontal. It is designated as M1. And the slope of line number 2 with respect still to the horizontal, with respect to the horizontal, it is designated as M sub 2. Okay? And it says from our concept, for them to be parallel, this slope here should be equal to this, right? So it's just by the definition, no matter how we prolong the two lines, they will not try to intersect each other, okay? They are always parallel. So this is the graph of two parallel lines. That is line number 1 and line number 2. With the designation, their slopes are actually M sub 1 and M sub 2. And for them to be parallel, M1 should be equal to M sub 2. So memorize this by heart. Okay? We are just discussing the relationship of the slopes. Okay? We are discussing concepts, so don't be bored. Okay? For perpendicular lines, an example of a perpendicular line is actually the x-axis and the y-axis because the angle between them is actually 90 degrees. X-axis, y-axis, a good example of a perpendicular line, right? Okay, I will try to erase this one so it will look good. The relationship of their slope is that m sub 1 is equal to negative open quantity 1 over m sub 2. Or if we try to simplify this one, the product of m sub 1 times m sub 2, if they are parallel, okay, they should be equal to negative 1. Okay, so memorize this one also by heart. Okay, the product of m sub 1 and m sub 2, for them to be perpendicular, meaning the angle between them is 90 degrees, they should be equal to negative 1. Okay, the additional special case here is the equation of a vertical line. If we try to consider point P with the coordinates A and B, okay, this is point P. Okay, the coordinates will be A and B, meaning the abscissa is A, the ordinate is B. The abscissa is A, the ordinate is B. And the problem is asking, or if we try to get the equation of a vertical line passing through A and B, what will be the equation? The equation of a vertical line passing through A and B. Vertical line meaning it is parallel with respect to the y-axis. The equation will be x is equal to A. It is this. So memorize this one also by heart. Okay? It's just by using our eyesight, right? If we try to get the equation of a line passing through the point with coordinates A and B, and for it to be parallel with respect to the y-axis, because the y-axis is actually a vertical line, right? So actually, if we try to get the equation of this one, we are talking of abscissa, right? Abscissa. Abscissa is actually, it's either to the left or to the right, and they are vertical lines. So the equation of a vertical line is actually x is equal to A. For a horizontal line passing through point P with coordinates A and B, if they are asking for the equation of the, what you call this horizontal line, passing through the points A and B, the equation will be equal to y is equal to b. A horizontal line is actually an ordinate, right? Right? So the equation will be y equal to b. Why equal to b? Because the horizontal line passes through the point with coordinates A and B, and the equation and the ordinate at this location here is actually b, right? So the equation of the horizontal line passing through this point here should be y is equal to b, right? So for a horizontal line, y is equal to b, vertical line, x is equal to a. Horizontal line, we are plotting an ordinate, right? Ordinate, it's either up or down, right? But for the given illustration, it's in the first quadrant, so this will be an up. No, this is a plus b. Okay? It's what they call this, top portion of, or it is at the top portion of the x-axis. That is y is equal to b, and this is x equal to a. So these two are the additional special cases under this, what they call this topic tonight. Okay? So at least we now know the relationship of the, what they call the slope of parallel lines, the slope of perpendicular lines, the equation of a vertical line, which is x equal to a, and the equation of a horizontal line, which is y is equal to b. Y is equal to b. Okay, let's try to bring out an example problem. This is just an easy one. It is just very tedious, very tiring, because in order for us to graph it, we try to be systematic. Okay, determine if the lines are parallel or perpendicular, and we are given two linear equations. Okay, 8x minus 2y is equal to 15, and y is equal to 4x plus 17. The problem is asking what's the relationship of the slopes of these two lines here. Will they be parallel or will they be perpendicular? Okay. Okay, let's try to bring out the solution, proper solution of this one. We will get equation number 1. 8x minus 2y equal to 15. We'll try to solve for y as a function of x. Okay. Because we are attempting to produce an equation y is equal to mx plus b, right? So solving for 2y, we place this on the right, then we interchange location. So 2y now will be equal to, okay, 8x, right? We transpose this on the left, this is minus 15. This one is actually on the right, but we interchange location, right? So 2y is equal to 8x minus 15, right? Solving for y without the coefficient 2, we multiply all the terms by 2. So the left hand side, this will cancel, right? It is now just simply y. For the right hand side, it will just be simply 1/2 times the quantity 8x minus 15. So if we try to distribute the so-called distributive property of fundamental operation, y is equal to 4x minus 15/2. So this is similar to the equation y is equal to mx plus b. So actually we correlate this one, m should be 4, and the what do you call this, y coordinate or the y-intercept is actually b. So m1 is actually positive 4, and the y-intercept is actually negative 15/2. So how do we plot this equation here? If we try to plot it, we compute first for the x and y intercepts. For this equation here, y is equal to 4x minus 15/2, right? The one with the right. So when x is equal to 0, y will be negative 15/2. So the y-intercept is at the location 0 and minus 15/2. 15/2 is 7.5. The location of the y-intercept is actually at this point here. This is almost negative 7.5. 1, 2, 3, 4, 5, 6, 7.5. Okay? And x here is 0. That's the y-intercept of the first line. The next one. When y is 0, to this equation here, x will be equal to 15/8. Right? 15/8. So 15/8, that's almost 2. So it passes through the abscissa almost 2. This is 1, 2, a little bit to the left, that's 2, 15/8. And the ordinate here is 0. Right? So we are now given the y-intercept, we are given the x-intercept. So if we try to plot the graph, you get a straight edge, then try to connect it. And we will designate this one as line number 1. Oh, at least we know how to, visualize the outcome of our solution. And the equation is y is equal to 4x minus 15/2. Okay, and the slope is this one. The slope with respect to the horizontal is actually 4. Positive 4 meaning it is a slope upwards to the right. It lies on the first quadrant. So this is less than 90 degrees. Okay, the next equation, what's the next equation? The next equation is an easy money, easy, right? Y is equal to 4x plus 7, and this is similar to the form y is equal to mx plus b. So in here, we will conclude that m is also equal to 4, right? So m2 here is 4. And the y-intercept is actually positive 7. Okay? So the solution of the problem here, the problem is asking, are they parallel or perpendicular? So our answer is M1, since M1 is equal to M2 equal to 4, they are parallel lines. Because slope of parallel lines, according to concept number 1, they are equal. As simple as that one. How do we plot the graph of y equal to 4x plus 7? Y equal to 4x plus 7, am I still on the camera? When x is 0, y is 7. So the y-intercept is at the location 0 and 7. When x is 0, the ordinate will be 7. 1, 2, 3, 4, 5, 6, 7, right? So this point here will be the coordinates 0 and 7, and that's the, what you call this, It is the point where the line crosses the y-axis. Okay? Or y-intercept. The next one, we reverse operation. When y is 0 for this equation here, x will be equal to negative 7 over 4. Negative 7 over 4 is almost 8 over 4 or almost negative 2. Meaning, the location of the x-intercept is actually at the location negative 7 4 over 4. So it's almost negative 2. So this is 1, this is 2. Negative 7 over 4 is almost less than 2, right? This point here. So the second line passes through the x-intercept at this location here. And the coordinates will be negative 7 over 4 and 0. Right? So if we try to plot the graph, where's my triangle? If we try to plot the graph, it's an easy money already. We got the x-intercept, we got the y-intercept. We just need 2 points to create a line. So we do like this, then we cross it. So this is line number 2. It is this. And the equation is actually y equal to 4x plus 7. Right? And its slope with respect to the horizontal is actually equal to 4. This is 4, this is 4, they are equal. So this line here is parallel with this. So this is the complete graph of the two given linear equations here. Okay, this is the complete graph. Okay, that's it guys. I think this will now be the end of the subject matter under what they call this linear equations. We finished all the discussions under here. So just in case when you go to higher mathematics, if you needed these concepts, okay, just recall your what you call this lecture under college algebra. And for those who are planning to study college algebra, just watch my channel. Okay, it's all there. Okay, good morning from Los Angeles, Professor David J.